In continuation to my previous video where I spoke about classes and objects, today I'm going to talk about the 4 principles of object-oriented programming. In case you've missed my previous video, please find the link below in the description box. The 4 pillars of object-oriented programming are encapsulation, abstraction, inheritance, and polymorphism. These words might sound scary to someone who is new to programming, and the lengthy complex explanations everywhere might double the confusion. This is why I have created this video where I can give you simple and short explanations with real-world examples for each of these concepts. In case you are new to my channel, please subscribe and click on the bell icon to get more such videos. Hello friends, I'm Soumya. Welcome to my channel. Today, I'm going to talk about the 4 pillars of object-oriented programming. So let's just get started. The first concept is encapsulation. Encapsulation is the binding of the data and the methods that operate on this data into one unit, just like a capsule. For example, I as a person can have properties like name, age, gender, height, and behaviors like walk, talk, eat, etc. All of this is wrapped into one person, me, and this is encapsulation. Going back to the example from my previous video where I spoke about car and bicycle, I have taken the RPM attribute and the calculate distance method that operates on this RPM attribute, and all of this is wrapped into one class car. Encapsulating related data and methods into a neat software bundle is a simple yet powerful concept that provides 2 benefits. 1. Modularity. The source code of one object is maintained independently of the source code of the other object. Now what this means? You can see that the same RPM property and the same calculate distance method are existing independently in their respective classes, and this is modularity. Second benefit is information hiding or data hiding. Encapsulation provides security of data by isolating the data by packaging it into the protective custody of its methods. Now what this means? The RPM property is being operated upon by the calculate distance method and is not accessible to the outside world. Hence, it has been encapsulated by this calculate distance and is secure from the outside world. And this is what information hiding is. The second concept is abstraction, which is a natural extension to encapsulation. It is the hiding of the unnecessary data from the user and exposing only relevant information. Abstraction is not limited to object-oriented programming or software design, but can be seen everywhere around in the real world. For example, a car has multiple implementations going inside, but for a driver driving the car, he is only supposed to know how to drive the car and not how the engine works or the radiator works. When we think in terms of software design, we need to handle large code bases for years that can change along the way. Abstraction handles these complexities and changes by isolating the implementations. A very simple example of this is the mobile phone that you're using constantly gets updated, but as a user, you're not bothered about those updates as long as the phone is working how it was working previously. Now going back to my example of vehicles from my previous video, we will see the class car and the truck car. In the class car, I am calculating the distance using the RPM and the time, while in the truck car, I am using the speed and the time calculations. As a user, as long as the distance is being returned correctly, you are not bothered about the implementations. And this is exactly what abstraction is. The third concept is inheritance, which is a mechanism in which a class acquires some or all properties and methods of another class. The class whose members are inherited is called the parent or the base class, and the class that inherits those members is called the child class or the derived class. Now going back to my real world examples, every child acquires some properties and behaviors of their parents while still possessing their own unique properties and behaviors. Inheritance solves the problem of reusing the common logic while extracting out the unique logic in a separate class. Going back to my original vehicles example, when I start designing my vehicle class, I will think of some of the properties that every vehicle possesses, like wheels, gears, brakes, and some methods that each and every vehicle will perform are move and stop. Now, when I have to create a car or a bicycle class, I will still think of all of these properties and all of these methods. So either I copy all this code into my car and bicycle class, or I can simply extend my vehicle class and get all these properties automatically. And then I can have my unique properties in the class like petrol tank, boot for the car class, and pedals for the vehicle class, for the bicycle class. I can further divide my cars into automatic and manual, while my bicycles into mountain bikes and city bikes. So you see how the class hierarchy can go as deep as needed. Vehicle is the most generalized class in this hierarchy, while the class automatic car is the most specialized class in the hierarchy. So you see, the further down you go in the hierarchy, the more specialized the class becomes. There's one more thing in the inheritance, that is the is a relationship. So every car is a vehicle, every bicycle is a vehicle, automatic car is a car while still being a vehicle. So you see how inheritance is a relationship between two classes. We are down to the most complex word, polymorphism, which means many forms. It is the ability of an object to take on multiple forms. For example, I as a person can act as an online instructor when giving these videos, as an employee in my office, and as a mother in my home. Polymorphism can be divided into two categories, static polymorphism and dynamic polymorphism. Static polymorphism is also known as compile-type polymorphism. Function overloading is an example of static polymorphism. It allows us to implement multiple methods within the same class, having the same name but different implementations. The essential condition for static polymorphism is to have the same name methods with different signatures. The difference in signatures can be achieved in three ways. One, in the different data types of the input parameters, the sequence of these input parameters, and then the number of input parameters. Now going back to my car class example, I have the calculate distance method. This method returns the RPM into time. I can introduce a new calculate distance method that will take speed as its input parameter and then return speed into time. You can see here that I have consciously taken the speed as an input parameter because this will differentiate both the calculate distance methods by this feature of having a difference in the number of input parameters. Static polymorphism is also called compile-type polymorphism because the compiler acknowledges the difference in the signatures of the method and then binds the method code with the method call during compilation. I'm going to discuss dynamic polymorphism in my next video, where I will first tell you how an object is instantiated or created, and then we will go into the concepts of dynamic polymorphism. Each of these principles mimic the real world, and hence, when designing a software around this real world problem, you can use some or all of these concepts. I will now conclude by summarizing all the benefits of OOPS: data security and modularity through encapsulation, isolating the impact through abstraction, code maintainability and removing the redundant code through inheritance, code reusability and code flexibility through polymorphism. As I already mentioned, I'm going to discuss dynamic polymorphism in my next video, so do subscribe to my channel. If you have any questions or clarifications, please put them in the comment box. If you want me to discuss any other technical topic, Do put it in the comment box as well. Thanks for watching.